Let's take a look at the key takeaways for this lesson, and it's a big lesson here in terms of what we're going to do moving forward. We have this big idea that's now floating around that we can differentiate functions of one variable. And in the case of what we looked at in this lesson, we differentiated functions of y with respect to another variable through this process called implicit differentiation. This ends up being a really big idea. The fact that we can take the derivative of one variable, in this case y, with respect to another variable, in this case x, is actually going to be a really huge idea for us when we start looking at a lot of applications involving all of our geometric formulas, lots of things that happen in physics we're going to be able to do this for. It's a really big idea that we can differentiate a function of one variable with respect to another. Just kind of a reminder as your roadmap here, there's really 4 steps that you'll go through in order to solve for dy dx. The first thing that you do is we differentiate both sides of the equation with respect to x. And remember, if you differentiate a function of y with respect to x, first differentiate it with respect to y, then multiply it by dy over dx, the derivative of y with respect to x. The second step then, after we get whatever process happens here in part 1, wherever we have dy over dx, we want to collect all terms with dy dx on one side of the equation. So if something does not have a dy dx, it needs to move to the other side of the equation. That allows us to do step 3, which is to factor out our dy over dx. And then fourth, once we have dy dx factored out, we can then solve for dy dx. And normally that's going to involve a step where we divide whatever dy dx got factored out of. We might multiply by the reciprocal like we saw in one example earlier in this lesson, but these 4 steps really are the roadmap in order to find dy dx when we look at this process called implicit differentiation. So really big that we're going to be able to do this moving forward. Take the derivative of a function with respect to another variable, and this is kind of the roadmap for how you would find this idea of the rate of change of y with respect to x, even if the function isn't explicitly stated as a function of x.